Hello, I hope that you are enjoying my lectures. And today, on demand of my students, I am going to introduce matrix. It is a part of mathematics, and this matrix is very much useful in higher studies, in even in research, to have a better understanding of a problem, you should have a clear idea of the matrix. So today I am going to introduce or I will be discussing about the matrix. Now we should have an idea over scalar vectors and matrices. What is scalar? Scalar is a number. Scalar just represents number. It has no direction. For example, 5 is a number, minus 5 also a number, minus 7, 0.5, 0.3, etc. These are the numbers, it has no direction. So these are scalar. Now, what is vector? Vector is a list of numbers. Vector is a list of numbers, but it has a direction. It has a direction. A vector has a magnitude and also a direction. For example, lift, displacement, force, velocity, all have directions. So these are the vectors. On the contrary, time, mass, area, speed, those do not have any direction. So these are scalar. Now, and what is the matrix? Matrix is an array of numbers. Matrix is an array of numbers. Look, for example, for example, this is a vector. This is an example of vector. This is the example of vector. Okay. Here, 4, 16, and 14. This is the vector. And scalar is just this number 5 minus 7, what I have mentioned. This number are the scalar. So, and look, this is the matrix. Matrix is an array of numbers. Matrix is an array of numbers. 6, 1, 4, 8. If you consider the column, then you find 6, 1, and the first column, and in the second column 4, 8. So this is an array of numbers. Actually, this matrix is used as a weight of a vector. As a weight, it is used or it is associated with a vector. Okay. So now look at this figure. Look at this figure where you can find three axes. One is x, s-axis, another is y-axis, and there is z-axis. Suppose a vector which is a list of number and represents 2, 7, and 8, 2, 7, and 8, and we plot these numbers on this three-dimensional space. 1, 2, this is 2, Okay, this is 2, and along this y-axis we have 7. So 1, 2, 3, 4, 5, 6, 7, this point. And now along the z-axis we have 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. So what is the vector? Vector is this arrow. This arrow represents the vector, and this is the 2 point. This is the 2 point. You can find the this is the 2. This is the 2, comma 7, comma 8 vector represents this arrow line. This arrow line represents the vector 2, 7, 8. Okay. Now, look, this in this lecture we have understood that what is scalar, what is vector, and what is matrix. Now look, now I am erasing all this marking. Okay. Now look, now determinant. The determinant of a matrix is the volume that the columns of the matrix span in space. Okay. Determinant determinant of a matrix is the volume that the columns of the matrix span in space. In our example, the matrix is, suppose there is a matrix that is A, and it represents 600, 080, 004. If you have this matrix, this matrix I am telling about this matrix. This is the 600, 080, 004. And now the determinant of this matrix can be calculated in this following way. This is the symbol of determinant. This is the symbol of determinant. Now determinant, this 6, 6, 6, and remaining part is this. We cancel out this column and this row. Okay, then we have 8004. So 8004. Now there is a positive sign. Now there is a negative sign, and 0. And now we multiplied 0. We cancel out this column and this row. So what remains? 0004. 0004. We find out this determinant. Now there is 0, plus, plus, minus, plus, plus, 0. We cancel out this column and this row. What remains? 0080. 0080. Okay. Now 6 multiplied with this determinant minus 0 multiplied with this determinant and 0 with this determinant. This is 0, 0. So there is no value, and only remains this part. Okay, this part. So, and now 6 is 6, and 8 multiplied with 4 will get 32, and so there is 32. So 6 multiplied with 32 we get 192. This is the determinant. This is the determinant of this matrix. And now this is the determinant of matrix. So now if we see in a three-dimensional space, then This is the x-axis, this is the y-axis, and this is the z-axis. Okay. Now look, now look, along this x there is 6 0 0 6 and 0 0 this point, and along the y-axis we have 0 8 0, so 8 is here, and along the z-axis we have 4 and 1 2 3 4. So if we find out the area, then we have to find out the area of this box. We have to find out the area of this box. So area of the box, a rectangular box, so it is the height, it is the height, and the area of this part. Area of this part, area of this part is nothing but the length of this, that is the 6, and the length of this, that is the 8. So that is the 4, that is the 4. This is the 1 2 3 4, this is the 4, this is 6. So area of um, this space is 8, 4 multiplied with the 6, so we get 24. 24, this is the 24, and now the length, the height of this box is 8. So 8, 24 multiplied with the 8, we get 192. We get 192. So determinant is nothing but the area, nothing but the area of this box. Okay, rectangular box. So this is the determinant. To have a clear idea over the matrix, we should have we should have an idea over the scalar, over the vector, and and also what is determinant. Okay. Now, now, now look. This is the another picture where we can find out the determinant, and this is the matrix. Suppose this is matrix B, and determinant of this matrix is 3 multiplied with 4 and minus 1 multiplied with 1, so 11. So now we put the values of the matrix in this two-dimensional space. Along the x-axis we measure the 3 1 3 1 2 3, and this is 1, so this point 1 3 1, so this point, and now 1 4, so 1 2 3 and 4, and this is 1, so this point. So we have the area of this, area of this is called the determinant. So 11 is the area. There is a algebraic equation. On this basis we can find out this area, but through the determinant we can find the area of this space is the 11. Okay. Now for students, suppose there are 4 students. Now we like to find out the clear idea. We like to spread some light on the matrix with a practical example. Okay, so for example, there are 4 students: A, B, C, and D. There are 4 students, and there are 3 subjects: subject X, Y, and subject Z. Now, students A, B, and C, and D, and student A got 85 in X subject and 60 in subject Y, okay, and 40 in subject Z. Student A obtained these marks in 3 subjects, and student B obtained 65 in subject X, and in subject Y 52, and in subject Z 35. Student C obtained 50 in subject X, 38 in subject Y, and 52 in subject Z. And student D got 75 in subject X, 59 in subject Y, and 45 in subject Z. So this, these are the information about the four students, and their their marks in the subject XYZ. Now we put these numbers as I have mentioned that matrix is an array of numbers. So matrix is an array of numbers. So we put these numbers in a matrix form. Look, 85, 85, this 85, and now, and along the column we measure the students, number of students, student A, student B, student C, and student D, and along the row we measure the subject X, subject Y, and subject Z, and these are the numbers. Student A obtained 85 in subject X, and student B 65 in X, and student C 50 in X, and student D 75 in X. And student A obtains 60 in Y, and 52 mm, is obtained by B, 38 is obtained by student C, and 59 is obtained by student D. And again, student A obtained 40 in subject Z, and student B obtained 35 in subject Z. Student C obtained 52 in subject Z, and student D obtained 45 in subject Z. Okay, so this is the matrix formation. This is the practical example, and this is the matrix form. So I hope that you have understood what is the matrix, and what is the importance of the matrix. Now look, now 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 you have the idea over this matter that, look, a matrix can be defined as a rectangular grid of numbers, symbols, and expression arranged in rows and columns. These grids are usually charted by brackets around them. Okay, this is the matrix. This is the matrix I have mentioned, and I have gathered some information and keep all this information in a grid, and within a bracket, brackets around them. And I hope you got the point. Now, the dimensions of a matrix are represented as R multiplied with C, where R is the number of rows and C is the number of columns. These R multiplied with C notation is also called the order of the matrix. R multiplied with the C, number of row multiplied with the number of column, is also called the order of the matrix. Now the types of matrix. Now look, the types of the matrix. There are various types of matrices depending on their structure. Let's explore the most common types. What are the most common? Null matrix. What is the null matrix? The matrix that has all elements, all zero elements. Okay, the matrix that have all zero elements is called a null matrix. Okay, and it can be of any order. It can be of any order. For example, we could have a null matrix of the order 2, 3. That is 2 is the column and 3 is the 2 is the row and 3 is the column. It is also a singular matrix. It is also a singular matrix since it does not have an inverse and its determinant is 0. If a matrix does not have an inverse and it has no determinant, determinant is 0, it, its determinant is 0, then we call it as a singular matrix. Okay. Now row matrix. Now row matrix. A row matrix is a matrix that is a row matrix is a matrix that has one row. Its order would be 1 multiplied with C, and where C is the number of columns. For example, look, this is the 1, 3, 5, 7, 9, 11 within a bracket, and here is a row matrix of order 1 multiplied with 5. It means there is 5 column, 1 row. Okay. Now column matrix. What is column matrix? It has only one column. So a column matrix is a matrix with only one column. And this is the example. Here is a column and column matrix of the order 3 multiplied with 1. Now the square matrix. A matrix where the number of rows is equal to the number of columns is called the square matrix. So look, here the number of the row is 2 and number of column is 2. So it is a square matrix. Now diagonal matrix. So a diagonal matrix is a square matrix. It is also a square matrix. Look at this example. It is also a square matrix. Its number of column is 4. Number of row is 4. So it is a square matrix. So a diagonal matrix is a square matrix where all the elements are 0 except for those in the diagonal form from the top left corner to the bottom right corner. This is the top left corner. This is the top left corner to the bottom right corner. This is the bottom right corner and the top left corner. Okay. This is the top left corner. All the elements are 0. And this is the bottom right corner. It is all the elements are 0. So if you have a, now I am going to look, this is, if I draw a line here, so all the elements above this line are 0 and all the elements below this line are 0. So this is the diagonal matrix. When all the elements above this line are 0 and all the elements below this line are 0, then it is called the diagonal matrix. And and here are the numbers. Along the diagonal, here are numbers. Okay. So now look, a special type of diagonal matrix where all the diagonal elements are equal is called a scalar matrix. Okay. This is a scalar matrix. This is an example of scalar matrix, and all the elements along the diagonal are equal. So this is scalar matrix. Now a scalar matrix whose diagonal elements are equal 1. Look, this is a scalar matrix. This is a matrix. This is a matrix. Also, it is a scalar matrix, and also its elements along the diagonal are 1. So this is the unit matrix or identity matrix. This is unit matrix or identity matrix. Now upper triangular matrix. Now upper triangular matrix. Look, upper triangular matrix. A square matrix where all the elements below the left right diagonal are 0. Left right diagonal are 0. Below the left right diagonal, the left right diagonal 0, 0, 0. These are 0. Is called the upper triangular matrix. Here is an upper triangular matrix. This is an example. Now, lower triangular matrix, a square matrix where all the elements above the left right diagonal are 0. Left right diagonal are 0. This is the lower triangular matrix. Lower triangular matrix. Here are the numbers. Here 8, 3, 2 are the numbers. These are not 0, but these are 0. These are 0. Okay? So a square matrix where all the elements above the left right diagonal are 0 is called a lower triangular matrix. Now the symmetric matrix. Now what is the symmetric matrix? A matrix whose transpose is the same as the original matrix is called the symmetric matrix. Only a square matrix can be symmetric matrix. Okay, you should have an understanding that only a square matrix is a symmetric matrix. The transpose of a matrix is another matrix that is formed by switching the rows and columns of a given matrix. The given matrix A, here is an example of a matrix A, is a 3-row and 3-column. It has 3 rows and 3 columns, and it is a symmetric matrix. It is a symmetric matrix. Since why it is a symmetric matrix? Since it is the same as its transpose. Transpose is 80. It is transpose. So this is the row. Look, this is the matrix and this is the row, row, row. So if we transpose the row, row will be converted into column. So 519, 519 and 186 row, 186 column, 965 row, 965 column. So rows are converted into column. When we make the transpose of a matrix and we find the same matrix, then it is the symmetric matrix. Okay, so in single line we can say that if A is a matrix and it is equal with its transpose, then it is called the symmetric matrix. An asymmetric matrix, it is the opposite of the symmetric matrix. A square matrix whose transpose is its negation is an asymmetric matrix or skew symmetric matrix. A negation of a matrix is a matrix formed by negating the signs of all the entries. Look, this is the example of the asymmetric matrix. Okay, asymmetric matrix 0 along the column 0, -1, 1, 2, 0, 4, -1, 4, 0. Now look, when we transpose it, we get 0, 2, -1 and -2, 0, -4, 1, 4, 0. So here is minus, here is plus, here is minus, here is plus, here is minus, here is plus, and here is plus, here is minus, and here is plus, here is minus, and here is plus, and here is minus. So a square matrix whose transpose is its negation is an asymmetric matrix or skew symmetric matrix. So in this lecture, I have tried to spread some light on the scalars, vectors, and matrices. And with a practical example, I have tried to clear the idea of matrix. What is matrix? And there are some pictorial presentation in a 2-space dimension and a 3-space dimension where the vector is imposed and how the vector is imposed in a 2-dimensional space or 3-dimensional space, has been analyzed in this pitch in this lecture, and also we have spread some light on the key important definitions of the matrix. Suppose the what is the null matrix, what is the symmetric matrix, what is the identity matrix. So this type of some important points have been discussed in this lecture. So I hope you have an understanding over the basic on the matrix. So thank you for enjoying my lecture.